There's absolutely no evidence that we live on a ball Earth. This footage right here, taken anywhere from 20 to 30 miles up in the air, completely debunks all of you who have said that you saw the curvature of the Earth from a plane, because most planes don't even reach 10 miles in the air.
Hello you buggers. That was a clip of video from a supporter of the flat Earth who's using someone else's video footage to make the assertion that the Earth is not a globe. The footage comes from a group of people called Seeker VR, whose YouTube content is primarily providing 360-degree virtual reality experiences. In this particular video, Journey to the Edge of Space, they launch a weather balloon with a camera rig dangling from the bottom of the balloon and flew to an altitude of around 94,000 feet. Now, what Mr. Flathead failed to mention was the camera rig dangling from that balloon was a full 360-degree camera rig. Unless you've been living underneath a technological rock, you'll know that a 360-degree camera rig can provide, like the name suggests, a 360-degree view of everything around it. In his video, the guy concludes that the views provided by the camera do not show any curve, and therefore the Earth is flat. He even has the audacity to crop the video so you don't have a chance of seeing the curve. This is the view as you would see it in the YouTube player. The link is in the description so you can check it out for yourself. Now, the ultimate way to view 360-degree video is with a VR goggle headset, but not everybody has these sort of technology to hand. But there's still a lot of information that we can glean from this 360 high altitude balloon footage. Before we delve into that, I need to go into some of the principles of the 360-degree footage and the cameras that can provide it. So here's a simple model environment with a 360-degree camera at the center of the video. And here is what is called the equirectangular map of the 360 camera. This is basically a single image that contains all the information for the full view all around. So here we are with a real 360 camera and its equirectangular map. The fundamental thing that makes 360 cameras work is that the camera lenses are totally irrelevant to the final equirectangular image map. What I mean by that is a 360 camera can be a simple forward and facing camera like this one, or it can be multiple cameras like a spider's eyes, looking in all different directions. The equirectangular image will be the same, albeit with higher resolution or better stitching solves. That's the method by which all the individual images are brought together into a single equirectangular image. Now, like any camera, we can tilt on all axes, and you can see how that distorts on the equirectangular map. Not much if we change the heading, but tilt forwards, and you could consider that the back of the camera view lifts to compensate. And the same happens if you roll. One movement in any axis has a direct effect across the entire view. And we can demonstrate that with the real 360 camera. So I can tilt forwards, backwards. I can change the heading. And if I rotate the camera, because tripods do not have 3 axes, I can roll as well. Now, what's interesting about the 360 camera is no matter what direction it's pointing, it never loses data. That data is still somewhere on the equirectangular map. Unlike a traditional 2D camera, if it tilts down, it loses my head. And that information is gone, it can never come back. So here's the 360 view, completely out of whack, but you can adjust this and bring the view back so that the horizon is straight and centered and that the ring is back to a horizontal band. Well, let's put our 3D representation of a 360 camera onto the surface of the Earth. I'm working in kilometers and using the radius of the Earth to be 6,377 kilometers, the equatorial radius. So on the ground, the horizon on the equirectangular view is directly center of the frame. But I've put the camera on a balloon and we will rise up into the sky. 95,000 feet to be exact, around 29 kilometers. And for no reason, our launch point is in the UK. Now look what happens to the horizon. It falls away from the camera's unwavering, unopinionated eye level. Why is that? Conversely, if we run the same animation on a flat Earth with a radius of 12,754 kilometers, the edge will always stay at the camera center line. Okay, let's look at a bit of maths. So we have an Earth with a radius of 6,377 kilometers, and we lift off the ground with an altitude of say 29 kilometers, and we end up with a distance to the horizon of 608 kilometers. To get that same result with a flat disk Earth, we would need to be around half that distance, or 304 kilometers radius. That's a pretty small Earth. So here we are, a flat Earth model that fits what we see on our globe Earth animation. That works, but only if the radius of the flat Earth is 304 kilometers. By the way, that bit of red you see on the horizon is the original globe sphere, just coloured red. I will come back to that in a bit later. Let's not bother messing around, let's just go straight to it, towards the end of the video when the balloon footage is at its highest, and let's just find a frame. I will overlay a 360 equirectangular protractor, if you will. Interesting. When we flatten out the horizon into as straight as a line as we can, the horizon appears to be below the center eye level of the camera. Let's look at another frame. Same thing. And another. And another. The viewable horizon is always below the center line of the camera. Now there can only be two possibilities of this to occur. Either the Earth is a globe or the Earth is flat and around 304 kilometers in radius. But wait, there's more. Remember how you only get a straight line on an equirectangular map if the points are equidistant from the camera. Let's take our 304 kilometer flat Earth and launch from South America. Oh look, there's a red colour of the original Earth model, but look at the distortion of the edge of the round Earth model. Let's try to compensate. It's totally impossible. In fact, the only way a flat Earth can be filmed with a 360 camera to match the footage we observe in the high altitude balloon clip is if the launch occurs in the centre of the Earth, the North Pole. On a sphere, it doesn't matter where you launch because the horizon will be equidistant to the camera at every point. There are a couple of videos out there using equirectangular footage to prove the Earth is flat. But it's obvious those people have zero understanding of the 360 principles and the image they use. Ironically, the footage proves the Earth is a globe, a flat horizon below the center line of the camera eye level. This, undeniably, case closed, undisputably open and shut case proves we live on a globe Earth. Now the mathematicians of you out there could probably use the footage of the high altitude balloon and calculate a rough estimate of the radius of the Earth. Have a go. So let's see more 360-degree video footage of high altitude balloons. The more evidence, the better. As for what I've shown you here today, maybe in the future I'll do a live hangout and we can bring the experts in to discuss what I've shown you. As for the flat earthers, well, it'll be interesting to see what answers they've got for this, see what they come up with. Anyway, till next time, you buggers. Bye for now.